Welcome back, Professor Bright here. Final video for this first section, and here we're going to focus on the descriptive form of a function because we've already focused on the other ones. And so really the key question we want to answer here is how can we tell if a relationship, and we might be working with different variables, but how can we tell if a relationship is a function? That's our main question we want to answer. And so here is our first example. Okay, so temperatures, we might remember, we can measure those in Fahrenheit, that's what we do in the US, or Celsius if you are in pretty much anywhere but the US. So Fahrenheit or Celsius were different scales. And so here we have a little description. We know that we can obtain the temperature of Fahrenheit by multiplying the Celsius temperature by 9/5 and then adding 32. And then the question is this a function? And so we need to figure out how to answer this. Well, okay, now that's a descriptive form. Let me just see. So I want to think about what information is given to me, and maybe I want to make a table. Imagine that. So we want to look at Fahrenheit versus Celsius. So we know it says so Fahrenheit. We take the temperature in Celsius. So if Celsius was 0, then we would get Fahrenheit by multiplying 0 by 9/5. Okay, it's not 0, and then add 32. Okay, and then if we have a Celsius temperature of 1, we multiply that by 9/5 and add 32 to that, and we would get 32 plus 1 times 9/5. And then if Celsius was 2, we'd have 32 plus 2 times 9/5. Okay, and then 3 would be 3 times 9/5 and 32 onto that. Okay, yada yada yada. You get the idea that if we wanted to get Fahrenheit, we have to take Celsius, multiply it by 9/5, and then add 32 to it. Hey, this is an equation. This is like saying f of x is equal to 9/5 of x plus 32. Well, if I have that, then I can look at a graph. I can graph this thing, and I can plot those points. So I might need to say, okay, here's 32, here's Celsius, here's Fahrenheit, there we go. And then we're going to end up, I'm skipping this for time purposes, but you're going to get a line, something like that. So then, oh, well, for every x, is there exactly one y output? Yup. Does the graph pass the vertical line test? Yup. So this is, yes, it is a function. And then once we have once we've established that it's a function, there's all sorts of things we can do. I can ask you, okay, what's the temperature, or if Celsius is 52.5, what is Fahrenheit? And you can do the math. Okay, or we can ask you what things mean. What does the 9/5 mean? What does the 32 mean? That sort of thing. Okay. So, great. This next one might take a little bit more thought. So, teacher wonders if there's a relationship between time spent studying for an exam and the score earned on the exam. And so two students both spent 120 minutes studying, and they earned 95 and 85 respectively. A different student, so a third student, spent 45 minutes studying and earned an 85. So then, well, what can we do here? Well, we can look at study and score. Okay, and I'm just going to make a list. So there's two students that studied 120, and they earned a 95 and an 85, and then another one earned an 85. Now, here I can tell you this is not going to be a function. Why? I have the same value of x. Okay, so that if you think of this as x and y, doesn't much matter here. But x and y, if you have the same x's, these have to be the same, but they're different. So that's not going to be a function. That's just using the straight definition. Okay, that's my abbreviation for function. Another way you could see this is you could make a little scatter plot. Okay, forgive me, I'm going to omit the scale or the labels right now for time purposes, but if I do 45, and this is obviously not to scale, and then we have 85 and 95. What we're going to see is there's that dot there, and then we have a dot here and a dot there, and well, we have a vertical line intersecting twice, so not a function. Okay, so takeaway. we can determine if a function exists from a description by representing the description in another form. So look at a table, look at an equation, look at the graph, okay? Or, as we did in the table, just use the definition. So for every x, there's exactly one y. Alright, and so that's going to wrap up this first video series here, and that is what you can expect in class. So in class, again, we're going to start with a video quiz, and any examples, any definitions that we do and have introduced in here are fair game. So please make sure to take notes, bring those paper notes to class, and you can use those on the quiz. Okay, and it'll be 5 minutes, 2 questions, and then we move on with our life. All right, we'll see you then.